Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. 3 sum, Leetcode 15. This problem is part of Blind 75, a curated list of essential coding interview questions. You can find the full list linked in the description below. Be sure to check it out. Before diving into this problem, I highly recommend solving the 2 sum problem first. In my opinion, it is one of the awesome problems to start with. I've already covered it on the channel, so be sure to check out the I button or the description below. Additionally, I recommend solving 2 sum 2, which is similar to 2 sum, but the input array is sorted. This will help you understand the concepts needed for this problem more easily. Now to the problem. In this problem, we are given an array nums and we have to return all the triplets nums I, nums j, nums k such that I, j and k are distinct indices. That is, I is not equal to j, I is not equal to k, and j is not equal to k, and sum of the three numbers is 0. That is, nums I plus nums j plus nums k is equal to 0. And notice that the solution set must not contain the duplicates. We will understand that with an example walkthrough. Then in example 1, for the given nums array, we can have three triplets which sum up to 0. One is at indices 0, 1 and 2 with elements -1, 0 and 1. The next one is at indices 1, 2 and 4 with elements 0, 1 and -1. And finally the last one is at indices 0, 3 and 4 with elements -1, 2 and -1. But the triplets in blue and green color are duplicates because they have exactly same elements and the order of the elements don't matter. And we can return only one of them as part of the answer. So because of this, we will return only two triplets as our answer. So either we can return these two triplets or we can return these two triplets. Any of them will be accepted as the answer. Now in terms of solution, the simplest way to solve this problem is to use the brute force approach, where we can run three nested loops with indices say I, j and k, where I is not equal to j and I is not equal to k and j is not equal to k. And I goes from the start to the end of the array and j starts just after I and k starts after j, continuing to the end of the array. And then we check if the number at these indices add up to 0. If they do and they are not duplicate, then we will add it to the result set. To handle the duplicate triplets, we can use a set to ensure we only store the unique triplets. For example, initially I is equal to 0, j is equal to 1 and k is equal to 2. And we get the triplets -1, 0 and 1 which sum up to 0. So it is a valid triplet. Hence we will add it to our result list. Then we move the k pointer forward to explore the next triplet. And now we sum up the elements and this time we will get the sum equal to 1 which is not equal to 0. So we move the k pointer forward to explore the next triplet and repeat the same process until we find j equal to 3 and k equal to 4, where sum of the triplets is equal to 0. So we add the elements at these indices to the result list as well. And we again continue with the exploration to find the triplet with sum equal to 0. And we find it at indices 1, 2 and 4 with numbers 0, 1 and -1, which is a duplicate of this one because for the triplets the order don't matter. So if we sort this triplet, we will get this triplet as -1, 0, 1, which is same as the triplet in blue. So to address this, we can use a Hashset and store these triplet as a sorted numbers. So this triplet is already sorted and not present in the Hashset. So we add it as is to the Hashset as well as to the result. For this triplet, the sorted order will be -1, -1, 2, and this triplet is not present in the Hashset. So we add it to the Hashset as well as to the result. And when we see this triplet, we sort it and we check that it is already present in the Hashset. So we will ignore it and continue with the iteration, and in the end we will return these two triplets as our answer. Now the time complexity of this approach is O of n cube, where n is the size of the input array because of the three nested loops, and the space complexity will be O of n for storing the triplets in the hash set. And now the question is, can we do better? And the answer is yes. Now we want to find a triplet, say a+b+c, such that their sum is equal to 0. And if you observe carefully, this problem is very similar to 2 sum problem. In the 2 sum, the goal was to find the two numbers such that they match the target. So here, if we fix one element at a time for the array, let's call this fixed element A. For example, here that number is equal to -1. Then our task is to find the two numbers B and C in the remaining array such that their sum is equal to -A. And for this number, the required sum will be equal to +1. So now this problem reduces to two-sum problem, where in the outer loop, we will select the number A, and then in the inner loop, we have to find the two numbers with a target equal to -A. For that, similar to two-sum, we will create a Hashset to keep track of numbers we have seen so far as we iterate through the remaining part of the array. So for each element in the remaining array, let's call it B, we have to find the number C such that C is equal to -A minus B. And if C is present in the hash set, then it will complete the triplet. So we will add the numbers A, B and C to the result set. If not, then we will add the element B and continue iterating for the search of C. And note that again, to avoid the duplicate results, we will only add them to the set after sorting them so that we can easily avoid the duplicate triplets. Let's see this in action. First, let's create the hash sets seen in result to track the numbers we have seen in the inner loop and to store the results respectively. Now we will run the outer loop with A as the fixed element. So first we start with number -1 as A. So the required sum will be equal to +1. So we have to now find the two numbers in the remaining array that sum up to 1. For that, we will run the nested loop on the remaining array with values as B. So first number we see as B is 0. So now we have to find the number C such that its value is equal to 1 minus B, that is equal to 1. But there is no number present in the hash set. So we will add B to the hash set. Now we move B forward. So now we have to find C with value equal to 1 minus B equal to 0. And that is actually present in the hash set. So one of the triplets for us will be -1, 0 and 1. And again we move the B pointer forward. So now B is equal to 2. So we have to find the number C such that its value is equal to 1 minus B equal to -1, and there is no such element in the hash set. So we will add B to the hash set and move it forward. Now since B is equal to -1, we have to find the number which is equal to 1 minus B in the hash set, which is equal to 2, and it is actually present in the hash set. So we will add the triplet -1, 2 and -1 to the hash set and similarly continue our iteration, where once the B pointer reaches the end of the array, we will move the A pointer forward and likewise go through all the pairs of A and B and try to form the triplets. Now the time complexity of this approach is O of n square because of the two nested loops, and the space complexity will be O of n since we are using the hash set. Now again the question is, can we do better? And the answer is yes. In terms of space, absolutely. Remember the two-sum problem where we used sorting and the two-pointer approach? There the time complexity was O of n log n for sorting, which was less efficient than the hash map or hash set based solution. But the space complexity was O of 1 because we were not using any extra space. And here, even if we use the hash map for solving the three-sum problem, we can't do better than O of n square in terms of time complexity. So why not just sort the array and use the two-pointer approach to save on space? Another bonus of sorting is that it groups all the duplicates together, making it easy to skip repeated numbers without using the extra data structure. This simplifies the implementation while maintaining the efficiency. So first we sort the array to enable easy identification of duplicates and efficient traversal using pointers. So again, similar to the previous approach, we will fix the first number or A in the triplet a+b+c, and then we will place the two pointers left and right in the remaining part of the array to identify the other values B and C that sum up with A to 0. And for all the three numbers, that is A, B and C, or first and left and right pointers, we will skip the duplicates to ensure only unique triplets are added to the result. Now let's see this in action. The first pointer points to -4, left pointer points to -1 and right to 2. So if we sum up all these three numbers, we will get -3, which is less than 0. So now which pointer should we move? Should it be left pointer or the right pointer? And the answer is left pointer. Since the sum is less than 0, we can increment the left pointer to increase the sum. And now we check the sum of the triplets, which is equal to -3, which is less than 0. So we move the left pointer again. And now the sum of these triplets will be equal to -2, which is still less than 0. So we increment the left pointer again. And now the sum at these indices become -1, which is still less than 0. So we again increment the left pointer. And now the left and right pointers meet. So now we are done with the inner loop. Hence we will move the first pointer forward, and left pointer starts from the next point of the first pointer and right pointer stays at the end. Now if we sum up the triplets, we will get the sum as 0. So we will add the triplets -1, -1 and 2 to our answer and increment the left pointer and decrement the right pointer to continue our search. And again the sum of the triplets is equal to 0, and hence we will add -1, 0 and 1 also to the answer and increment the left pointer and decrement the right pointer to continue our search. And now since left is more than right, we can't continue further. So we move the first pointer forward and place left and right pointers accordingly. Now if we again take this -1 as the first element in the triplet, we will again get the triplet -1, 0 and 1, which will be duplicate. So to avoid this, we will skip this number and move the first pointer forward and place left and right pointers accordingly. Now the sum of the triplets is 3, which is greater than 0. So we will decrement the right pointer to reduce the sum. And now the left and right pointers are at the same location. So we are done with this iteration as well. And we try to move the first pointer forward, but we cannot because for the triplet we need at least 3 elements, and this was the last triplet that we processed. So now since we are done with all the elements, this will be our answer. Now the time complexity of this approach is O of n square, because first we sort the array, that takes O of n log n time, and after sorting we run the nested loop, where in the outer loop we select the first number, and in the nested loop we run the two pointer approach to find the triplet which sums up to 0. And the space complexity will be O of 1, as we are using few variables here and there. Here is a quick code walkthrough of the algorithm we just talked about, with Java code on the left and Python on right. First, let's create an empty list to store the resulting triplets. Now let's sort the input array in the ascending order and iterate through the array, fixing the first number of the potential triplet. So we loop from first element all the way up till n-2th element, because triplets require 3 elements. Now we will check if the current element was same as previous element. If it was, then it is a duplicate, so we will skip it. Otherwise, we will fix the first number in the potential triplet and use the two-pointer technique. The left pointer starts just after the first number and the right pointer starts from the end of the array. And now while left is less than right, we will take the 3 numbers at the respective indices and sum them up. And now we check if the sum is equal to 0, that means we have found one of our answers. So we will add these triplets to our answer list and move the left and right pointers toward the center. That is, increment the left pointer and decrement the right pointer to continue with our search. And now to avoid the duplicates, we will skip the values for both the pointers. So while the element at the left is a duplicate, that is the element at current left pointer is equal to the element at the previous left pointer, then we will continue incrementing the left pointer. Similarly, while the element at the right is a duplicate, that is element at current right pointer is same as the previous one, then we will continue to decrement the right pointer. Now here the sum was equal to 0, so we can find the triplet. But if the sum was less than 0, then we will move the left pointer to look for the larger values. And if the sum is greater than 0, then we will decrement the right pointer to look for the smaller values. And after traversing the array, we will return the list of triplets, which will be our answer. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.